Okay, guys, so let's begin with our session today. All of you can hear me clearly. There's no problem with the stream, right? All of you can hear me clearly. There's no problem with the stream, right? All of you can hear me clearly. There's no problem with the stream, right? Okay, so let's begin with the session for today. So first, open up an empty project, Unity, the new project in your Unity version, whichever one you have. Okay, so when you open up your default project, you will see the main camera and directional light available. Yeah, so these are default components in what is called a scene. So a scene in Unity is basically a way of representing how the game will look. By default, the scene will be named a sample scene. You can change the name of the scene very easily. So first we'll talk about the UI of Unity. So there are by default, you can see a few windows here. The hierarchy, scene, game, inspector, project, console, these are all called windows, and they have different parts of functionality of the game engine. So the hierarchy window is used for showing the game objects and the scene that you are working on. These main camera and directional light are both used for their game objects. Basically, each everything you'll see under a scene is called a game object. So the main camera is the camera and the directional light is lighting for the scene. uh, you can see that you have currently there by default scene will be selected here. You can click on game to see the camera's view. If you click on the camera, you'll also see a small preview over here. Now, when you click on a game object, you see a certain change in the inspector window. The any game object here, it's the main camera, will have a transform component by default. Each part here is called a component. So the main camera has three components here: the transform component, the camera component, and an audio listener. So we'll talk about the component part later. Now the project window shows the assets or the game objects that you can have. Okay, so now you can change the transform either using this, or either basically by using the value in the component or dragging the arrows, as you can see in the scene itself. The Now the console window is used to show errors. If you get a few errors while starting up, it's fine. It's usually not a big deal. Some errors might pop up based on differences of versions of Unity or some part of the assets missing. It's fine. So an asset is basically any kind of object that has anything to do with a game. It could be an image, text, a game object itself, or anything of that sort. So you can change the layout if you want in under this panel. It's not necessary, and I find the default layout comfortable. If you guys want to tinker around with that, it's all right. So next we'll move on to discuss creating new objects. So as of right now, the scene looks a little bleak. So we can always create new objects by right clicking, and you can see you have a lot of options here. You have copy, paste, duplicate, delete, and then you have these basically help you create new game objects. So we'll start with creating a cube. So if you switch to game view, you can see that the cube is placed at some random point with respect to the camera. So you can select each axis in Unity by using these controls over here in the top right of the scene view. So that you can switch to axis easily for relatively easier movement. Oh, and you can again click on the camera so to view the camera itself. So you can see I moved the camera around in order to give the cube a decent perspective. So you can see the cube very clearly in the game object hierarchy and in the game view. So these are basically scene view and game view. Scene view helps you render the scene as a whole. You can move around using your middle mouse button, right mouse button. You can using the right mouse button, you can change the view. Using the middle mouse button, you can move around, and you can use your left mouse click to deselect objects. These are the default controls. You can change them under editing the settings. Next we'll move on to these tools that you see on the top left of Unity's editor. Here, these tools are usually used for affecting basic functions of game objects, the ones that are available in the transform component. So this tool is used for moving around. This tool is used for moving the objects around. You can see these axes and you can select each axis and move it. You can see these small boxes to move it around a little more freely. The next tool is used for rotating the object. So you can rotate it about its X, Y, or Z axis, as you can see here. You can press undo at any time to go back to your previous setting. Then you have the scaling tool. This is used to scale up or down the object, and it's fairly simple. Now, instead of actually going and clicking here, you can use the QWERTY. Uh, you can use the QWERTY keyboard part to quickly switch between different settings. Q is for the hand movement tool, W for scale, W for the position, E for rotation, R for scaling. The other two tools are not going to be useful to us now. We'll be talking about them later. The last tool is just accumulation of everything, but I believe it makes it a little confusing. So I generally don't prefer to use it. The rect tool is going to be used when we talk about 2D components. So you can see that if you create different objects right now, you create a cube or a sphere or cylinder, basically anything, you can see that they are all having the same dull white color. So in order to give a new color or give a new material as such is what we call these in Unity. So a material has certain properties. If you click on any game object which you can see having a particular color, you can go and you can see in the inspector panel that it will have a material attached to it. So the material has certain properties. This is the default material that Unity has. We can create new materials by right clicking in the project window, going going create and click on material. You can give any name. So I'll just call it red because I'll select a red material. So yeah, you can basically see that it's really easy to pick a color. So I'll just pick a red color for this. And in order to attach this material, so these game objects are all having the default material. You can attach a material by simply dragging and dropping it onto a game object. So you can see that all three are now appearing red. So these are just basic parts of the game. Something you can probably figure out on your own. Now let's move into a little more detailed perspective. So now we'll move on to something known as parent-child relationship. So how many of you are familiar with the class inheritance that occurs in Java, if any of you, or in any object-oriented programming language? Those of you that are, give me a like on the chat. Okay, so basically, a parent-child relationship is where one part of basically where one object's movement, rotation, and scale can be copied onto another object. And so, if you move one object, the other object moves corresponding to it. So let's say that here you can see I'll drag the cylinder onto the cube. So now the cube and cylinder have a parent-child relationship. Here the cube is the parent and the cylinder is the child. So now you can see that if I move the cube, the cylinder moves along with it. But if I move the cylinder, then only the cylinder moves. This is because the cylinder moves now with a scale, with basically you can see if you use the transform, it moves with respect to the cube. It doesn't have a transform of its own. Basically, if I set this to 0, 0, 0, you can see that it will be in the dead center of the cube. And now if I change the cube's position, even though the position of the cylinder has changed, the transform position still remains the same. This is because now the cylinder only has a local scale with respect to the cube itself. And the same goes with scaling up and down. So if I scale the cylinder, let's say I make the y component of the cylinder 2. And now if I increase the y component of the cube, even the cylinder will have its scale changed accordingly. Parent-child relationships are going to be really important when we are talking about player when we are making a game player. So basically, all guns, cameras, and such game objects which are necessary to be moved and synced with the player can be simply made as children of the player, and then you don't need to have different, and then you don't need to refer to them and make them move with respect to the player. So it saves a lot on computation time. So now let's explore a little more in detail what components are. So if you go to the main camera, you can see that it had three components as we discussed earlier. So the transform components are relatively simple to understand. It's just the position, the rotation, and the scale of the object. So from now on, every game object will probably have a different set of components. Here you can see the camera component has a lot of different options. We won't be discussing them in detail now. We'll be discussing camera later. So let's move on to a simpler game object relatively. So you can see the cube has a cube mesh filter, a mesh renderer, and a box collider. So a mesh renderer and a mesh filter describe how an object will look and how it will appear in a scene. So if I turn the mesh renderer off, you can see that the cube goes, that you can't view the cube basically. The mesh renderer actually computes how the cube will look and how it will appear. Similar in a different way, the box collider is used for physics and basically for checking collisions. So if you switch off the collider, then when two objects collide with each other, you can simply pass through the cube. The cube basically won't collide with any other object. So before I show the working of that, you can add components by going here. So a component can be anything. You have a lot of options here. So we'll add something known as the rigid body component. So a rigid body component is generally used when you want to apply physics to a particular object, because the rigid body components allow you to define the mass, the drag, angular drag. Basically, these are values related to friction. You can choose whether or not to have gravity affect the object over here, and you can use, then there are a few more relatively non-important features. Then they even have constraints in x, y, and z, so you can freeze the position of a particular object if you want to. So let me delete the cylinder and the sphere and show you how rigid body acts. So basically, you can create a plane and place the plane below the cube. So now you can see that I have the rigid body component on the cube. If I press play now, you can see that the cube falls down and acts on, and gravity acts on it, but it doesn't act on the plane because the plane doesn't have any force or any movement forced upon it. And this is where the box collider comes in. Basically, all objects will have a collider of one of the different colliders that are available in Unity. They have cylindrical, spheres, and different kinds of collider. Now you saw that it collided with the plane and stuck at that place, right? If I turn the collider off and play the scene again, you can see that the cube just passes through. This is because now there was no boundary or radius on the cube to detect collisions. On the other hand, you can even see that there are certain these center and size components on the collider. So if I increase the y component to, let's say, 5, right, or maybe something like 2. Now if I play the scene, you can see that the cube stops in midair. It looks as if the cube has stopped in midair, but actually the collider for the cube has a size bigger than the cube itself. So as soon as the collider uh, basically collides with the plane, there's a collision and the movement of the cube is stopped. So in such a way, there are many components, and you can add scripts or basically code through components. Whenever you want to add a new script, you can just type in whatever you want. So let's say movement, and then you'll get an option for new script. We'll talk about coding and scripting in further classes. We won't be exploring that right now. So let's move on to the different kinds of game objects that you can create. So you can see that here you have cube, sphere, capsule, cylinder, plane, and quad. Now these few are self-explanatory. On the other hand, you have something called as ragdoll, terrain, tree, wind zone. So basically, let's start from here. So text mesh pro text is used to add text into a scene. So whenever you want to add text, you can either choose text mesh pro text or you can choose 3D text. If you don't have this option, don't worry about it. It's something that I have imported as a separate package. We'll talk about that in a while. Ragdolls are animate objects which have a very low mass and are used to show the working of physics. Then there are terrains. Terrains are used to basically the function that we have for the plane here is used for a terrain, but a terrain is used for a large scale game when you're making open world RPGs or basically role playing games like Skyrim. You'll use a terrain to design and draw the base of the map or whatever world you're exploring. Trees are used to show trees on the game in the game. Wind zones are used to show the effect of wind on objects, and 3D text is again self-explanatory. We'll be exploring 2D text in further classes, so I won't be covering these now. In effects, you can see you have particle system, force field, trail, and line. So particle system is something which is going to be used more prominently by us. So I'll discuss that. A particle system is, yeah, as you can see here, a particle system is basically a center point from which particles will be coming out and getting destroyed in after a while. So there's a lot of setting in the component in the inspector panel here. So the particle system components has a lot of different options available here. You can see that there's a duration, there's a looping constraint. So if I switch off the looping and restart, you can see that it'll switch off after 5 seconds here. So let's say that we don't want the particle to be running this long. We can change the duration. Let's change it to, let's say, 1 and restart. So you can see that after 1 second it turns off. Then it has a lot of options. We'll be discussing these further when we talk about FPS and gun shooting effects and all that. Just to give you a basic idea, I talked about it. Other game objects include lighting, like you have directional light, point light, and spotlight. So by default, every scene comes with a directional light. You can see that if I move the light around, it will make an effect to the scene's lighting. If I change the intensity, then the lighting changes drastically. You can change the color of the light. And you have quite a few options here. Again, when we discuss lighting in detail, we'll be covering these better. The other two main light sources that you will be using are point light and spotlight. So a point light, as it sounds, is something that is where light is emitted from a point. These are usually used to represent torches or objects that are at a static position in a light. You can even use it for explosions when you want lighting to be suddenly changed at a particular place. But particle systems are usually better for that. Then you have spotlights, which, as the name sounds, are used for showing spotlights. You can see that the lighting changes a bit. You can see the lighting effect right on the shadows. So a lot of these lighting computations are done by Unity itself, but you can change the settings to suit you. Then you can add an audio source or an audio reverb zone, a video player, or more importantly, when we talk about the UI, you can add text. Again, Text Mesh Pro is a feature that I have imported. If it doesn't show up in yours, don't worry about it. You can add images, and you can add something called a raw image. We'll discuss it in further sessions. Basically, raw images are used for dynamic rendering. Like when you have a mini map and you want it to be changing continuously, suited on the player's requirements. Then you have buttons, toggles. Usually these parts are used more proficiently when you're designing menus. So and then you have the camera option to create a camera object is similar to our main camera. So an audio. Now we didn't talk about the audio listener component. The audio listener is just a component we use for being able to listen to audio from that particular point source. So if an audio source intersects with an audio listener, only then will you be able to hear the audio in that particular point. Okay, so let's now talk about assets. So you can see that we have very limited options for objects here. We have only about five or six different kinds of objects in 3D modeling, but we'll definitely need more than that. So what you can do is either you can design your own game objects using Blender or any 3D platforming, 3D development software, or alternatively, you can use the ones which are available in Unity as assets. So first click on the window button and then asset store. So let's just wait for the asset store to connect. So as I talked before, assets are ready-made game objects or images or anything that can be useful for the game. So let's try something. Let's just search for a robot. So you'll get a lot of option. You'll get a lot of options here. Most of them will be paid, but you can toggle that in price high to low and other filters that are available on the store. So I already have it downloaded. You'll have a download option over here. You can import the asset. So Unity will do most of it for you. As you can see, when we see the asset, it has many different folders. It has a models folder, a prefab folder, a script folder for animation, and a demo scene. So you can take whatever you want. Usually you need all of the models and the scripting if you are to use it properly. So let's import the object as it is. This might take a while. So while the game object is being imported, it's always preferred to, okay, a prefab is a game object that can be spawned continuously. So basically, let's say that you have a recurring enemy, or you have, say, a bullet pack or something like that, which you want to generate at random places in your game or the game scene. So let's say that I want to use this particular model of the cube that I've created here in multiple different times in the game. So what I can do is I can drag the cube here, and here this cube becomes a prefab. So now I can create as many copies of this as I want simply by dragging it here. So a prefab is basically a ready-made model for a game object. You can change and more importantly, whatever changes you make to the prefab will affect the changes that are made to the game objects in your game. So you can see that I changed the color just on the prefab, and yet the color change corresponded to all the three cubes because they derive from the same prefab. Any change to the prefab will affect all three of them. So for now, let's remove these. So basically this too is a prefab, which is a ready to use game object by design. So what you can do is just drag the game object here. It just looks like a sphere for now. You can import any other game object. It's perfectly all right. Basically, when you click play, you can see that a particular animation plays where the robot opens up and moves around a bit. So as you can see, importing assets is definitely a good option, but creating them on your own is usually uh, better. This is because if you create the game object on your own, you're better used to it and the script. So I don't know how the animation in this works as of right now. I'll have to read the code for it and understand it, which is usually not documented properly. So it will be tough to understand. If you create your own game object, it's easy to refer to and use, much easier than the one they have shown. But these are at times really useful, especially the ones which Unity provides. So uh, because these will give you ready-made options. Also, you can create your own prefabs in a particular. If let's say that you're working on a particular game and you want to use some game objects from that game in another game, so instead of actually making the game object from scratch again, you can make the game object a prefab and then use it in your other game as well. This feature is extremely useful because this allows really good reusability of code as well as reusability of the work you would have done before. So now let's move on to something which is known as the package manager. So again, go to Windows and under that you'll see the package manager. So basically, over time, there have been assets in the asset store which Unity has found to be extremely necessary and useful in their own in their own editor itself. They basically have a set of all such assets available to you through the package manager. This can be one asset or multiple assets all stacked together, which give very good use. So as you can see, package manager is really easy to use. You can just click on a package which you haven't used, and then you can select the version you want, and then you can install it. So I won't be installing anything right now to show you, but it's really easy to do it. So a few tips that we'll use throughout the session. Uh, Basically, a few shortcuts that will really help you guide yourselves through Unity. You can always, if you have a particular game object and you want the same game object, but you do not want to create it a prefab because you'll be making changes to it, you can press the shortcut Control D to duplicate the game object and change the name. Let's say that I want a cube of the same size and same components, but I want it to have a different material. So I just selected the game object, press Control D, and it created a duplicate game object of that. Then I can simply create a new material. Let's call it blue, and let's something blue. So you can see that it's very easy that the game object has all the same components It has the rigid body component, which if I create a new cube, wouldn't have. It has the exact same scale and the values of rigid body as well as box collider as the game object I duplicated from. So basically, it creates a duplicate. It creates a complete duplicate of the game object, and then you can change it as you want. So it's really useful. Um, so have I been going too fast, or do you have any of you have any doubts? You can always ask for doubts on the channel. That's one of the main advantages of the session being live. Okay, so I'll move on. You can see that there are a number of windows here, and the general windows we'll usually have. Some of you might have the services window open. So the services window is something that Unity provides you with to sync your services better with the cloud, which Unity provides again. So you can turn off ads, analytics. We'll have a separate session to discuss these in detail. But a large part of Unity actually works well with the services. You can click on go to dashboard over here to go straight to your account on Unity. You can also view your account here. And then there's this feature called collab in Unity. So how many of you are used to using something called GitHub or any other version control system for any of your projects before? It's fine if you aren't. Okay, so basically, Collab is Unity's version control system, and it allows you to share and work together with your friends more frequently. Basically, if you start a new Collab session, let's say that I sync this version with Collab, you can see that it takes a while to sync your project online. Yeah, you can see there's a lot of pluses that will appear in your assets. So basically, now the project is available for collab. You can publish your changes. So this creates a copy of your project online. You can go online, or you can go online either through Chrome, or you can go online through the options given here. Basically, so now it I made a commit on the website. A commit is it saves your local file and tells you that it's synced with the file online. So let's say that I make a change in the material here. So let's say I change the material blue to green, and let's say that I make changes to the prefab that we imported. Let's say I change the scale to 20, 20, 20 by default, and I save. You can see that now it tells me that I have changed these materials and I should publish these changes. So this helps a lot when you are working in a team, because any changes that you make can be synced very easily, and you can always see all the changes then where they're applicable in the project. So now let's move a little onto the details of lighting. So you can see we talked about the lighting color and all here. You can change you can change the type of light over here. So you don't need to specifically import a particular light. And if you'll notice that if you change the rotation, the shadows change themselves in real time. You can change the effect of shadows too, in fact, by selecting hard shadows in shadow type. And there's a lot of features over here where you'll see there's a strength which allows you to control the strength basically, or the transparency of the shadows itself. Talking about transparency, also there's also an important feature here. that when you select albedo, you can see that there are RGB values, which are basically red, green, and blue values. And then you see a fourth extra value called alpha. So the alpha value again is used for checking the transparency of an object. So if I change the alpha value and reduce it, and then you can see that if I apply this, then that the object becomes a lot more transparent. And if I change the alpha value to absolutely zero, you'll be able to see through the object a lot more clearly. And you can apply this at any time. Then there's other features such as the metallic and smoothness. So smoothness is basically to tell you how smoothly the color will operate. Let's change the alpha value back to full. And then the metallic character will be the reflecting character of. The more metallic it is, usually it'll reflect that more light. So if I change the metallic character to very high, sorry, yeah. So this is the metallic alpha. Sorry, and see that changing the alpha changes the transparency of the object. Then there are a few more features such as normal map, height map, occlusion, detail map. So basically, we can have materials to render a lot more detailed values than just plain colors. If you create textures, you can assign those textures here. And when you assign the textures here, you can see that the textures will be reflected onto the material. We'll talk about that a little more in future classes. Then there's this feature called emission. So let's say that you're making. Yeah, material changes made into materials do affect in real time. So let's say that you're working to make something of a lava kind of object. You have a flowing lava object, so you'd want the material color to be something between a red and yellowish color. So basically more of an orangish shade. But that's not enough because lava is supposed to exude light. So when you make an emission, you can select the color here. You'll see that the color of the object changes drastically. It doesn't just affect the object. So let's say that I create a 3D object, let's say another cube, and I place it here. One second. Although it's really light, it affects the lighting of other objects as well. So if an object emits a particular shade of light, like it does this material here, you can already see the change it made to the object itself, but it also makes a slight change to the objects near it. So there will be a reddish shade in the objects near it. And again, you can attach a texture here to affect the emission rate of different parts. So let's remove this cube. So guys, any doubts up till now, or uh, any problems or issues that you faced? So I made a lot of changes, but now I want to change back to my original setting. You can always go back to the initial commit. So if I press go back to, then it'll change all the settings that I changed back to that previous commit. So by the initial commit, there were no assets. Again, if I want to go back to the more recent one, it's yeah. You can This helps you keep track of changes and basically helps you a lot more in keeping tracks of errors that you would have made. It's a lot more useful when you will start coding, and especially when you're working with when you are not when you're not happy enough with your local saves, because it really helps when you're working in a team. The collab feature. You can make your own textures using Photoshop. we won't be covering how to make your own textures in the game dev workshop. There might be a small session on it, but not more than that. You can learn that very easily online, or you can use pre-made textures which are readily available. So let's say that I want to import a particular texture. Or you can even see that in the model here, you can see that he's made a particular texture here. If you see in the inspector, you can see the video in the asset that you imported. Yeah, as Nicola said, we can always import ready-made textures, and that's usually better because designing your own texture becomes a really tough job unless you're making it for a simple, relatively simple game. You have you have to put in a lot of work into it. You can see that if I drag the texture on as well, you can see the change in the object. So basically, when I drag the texture on, it creates a new material of that texture. You can do the same for any image. Let's say that you want a particular image in your on your game. You can actually just drag the image into Unity and then copy paste it onto an object in the game itself. So yeah, any doubts? I'll wait for 2 to 3 minutes for you guys to catch up. So if you guys don't have any doubts for the basic session, I'll be ending over here. So let me know if you have any doubts. Let me know if I went too fast or too slow. This was just a basics only session, so I didn't want to cover up too much. So if you don't have a doubt, just put a like and you can leave the chat. Okay, so a texture on a material is basically how the layout of the material will be. So you can see that when I drag the texture onto the cube, it created a new material, right? So when you go to this material, you can see that this texture map is attached to the material and it has a whitish color itself. If I change the color, it will affect the plain parts of the texture. Basically, what a texture does, uh, basically what a texture does is that it gives a layout of what parts will be what color. You can see that when I change the shade to a little reddish, you can see that the white parts are affected completely, and then it's that part is directly red. The parts that were gray were given some part red but weren't affected completely, and the parts that were black were not affected at all. You can do the same thing for various colors as well. Usually black and white textures work fine. But yeah, you can see that the effect of the textures is visible over here, right? So creating texture material would be more of a thing that you would learn better from an online website. We both also don't have that much of an experience in creating textures. Okay, moving on to the ground terrain. So a terrain works completely differently as opposed to objects like cube and plane that you see here. On a terrain, you don't really need, you can use textures to paint on the map. Okay, wait, I'll just show it to you. In create a 3D, let's create a terrain. So you can see that the terrain is relatively quite large compared to this is usually size of a map that will be available in your proper open world RPG. So let's now, in order to paint the terrain, you can select tool. Then to paint texture, you can edit textures. Let's add layer. So as of right now, we don't have any texture which is terrain ready to available. But to answer your question, textures will be used to paint terrain, but they won't be limited to just textures. You can even use 3D objects such as trees and flowers. And yeah, a terrain works very differently. We'll be covering terrains in further sessions. We won't be covering terrains right now because it'll take a lot more time. But basically, using text, you can use textures to paint terrains, but you can also use 3D object itself, not just materials. Like if you have a tree object ready, you can paint the terrain using trees, and you can change the settings for each of them under this function. I hope that clears your doubt. Anyone else who has a doubt? Okay, so if you guys don't have any more doubts, I'll be closing the session over here.